Okay. So unit 2 is tires. That is in vehicle dynamics. We are going to study about tires. Okay. So you can see what are the contents in this unit. That is, you'll be studying about forces and moments acting on the tire. And you'll be studying about tire structure, cross play, then radial play, like that. Okay. Then you can see the different forces acting on the tire. That is in longitudinal direction. That is in x direction, then lateral direction, that is in y direction, then z direction, that is in vertical direction. So we are going to discuss about all the forces acting on the tire, and we are going to address about slip angle also. Angles, that is, we are going to define what is a slip and what is a slip angle. Then we are going to define about the important property of the tire, that is due to elastic property, that is hysteresis loss, that is called as rolling resistance. Then we are going to address tractive and cornering property of the tire. Tractive means how far it will be able to give the propulsive force and how it is going to respond in cornering. Okay. Then we are going to discuss about how the tire will perform when it's going to run on wet surface. That is if you're having a water or some other surface other than conventional road, we are going to discuss about the performance of the tire. Then we are going to discuss about ride property of the tire, how the tire will be influencing my vehicle ride. Okay. Then we'll be discussing the important formula in the tire, that is called magic formula tire model. What do you mean by magic formula tire model? No, the same formula can be adapted for all possible combination. That is, if I'm having one set of input, corresponding outputs will be obtained. If I'm having another set of inputs, for that corresponding outputs will be obtained. There is no need to go for a separate formula. So this formula I've and to find the number of outputs, and I can make a combination. Okay, that is for my desired input, what is the desired output. So the formula will not be changed, only I can change the input and I can understand the output response. Okay. Then I will be we'll be studying about tire road friction, that is how it will be going to influence. Okay. So that also we are going to study, and we are going to test the tire, that is experimental testing procedure, how they have done on various road surface and other things we are going to discuss. So come back to first unit, this will be purely theory only. Okay. So it will be easier only when you are going to understand, it will be more easier. Okay, I think it will be more visible now because I have given a maximum view. You can see that is we are having a tire that is making a contact with the ground. So the portion of tire which is going to make a contact with the ground, so that is known as a contact patch. So the portion of tire which is going to remain touch with the ground. Okay, you can see in the top view. So this one so this one is a side view. Front view means you will be able to see only the front portion of the tire. Okay, you can't see this wheel rim and all. Side view only you can see the wheel rim, and the top view will be you'll be able to see the contact patch. That is the length of the contact patch. Will be able to see. So whenever I'm going to study the tire, no, what I'll be doing now, I'll be keeping the origin at the center of this contact patch. So the origin of the reference will be at the center of the contact patch. Already you know what is x-axis, that is along the longitudinal direction. The x-axis is defined by the intersection of ground plane with the mean plane of the wheel. Okay, you can define like this also. Otherwise, we can say in the longitudinal axis. Okay, then z-axis will be perpendicular to the ground. Okay, in the side view, you can see the cursor movement perpendicular to the ground and pointing outwards. And the y-axis will be like this. You see the cursor movement. Okay, so in the top view, I can see y direction, I can see x direction. In the front view, that is in the side view, I can see what z direction. Okay, so you should be comfortable with this. And regarding this course, no, that is in unit 2. So all my PPT contents have been taken from the book. That is, you can see Rajesh Rajamani is a famous author in vehicle dynamics and control. So most of the slides I have taken from that book only. And for some slides, I have referred Gillespie. That is also a famous book in vehicle dynamics. Then Wong. Okay, so comprising these three books, the entire PPT is made. Okay, so you can see this one is what tire plane system. Okay, okay. So let me zoom it first, then I will go to the explanation. See, this one is Z direction, this one is Y direction, and this one is X direction. Okay, so now I am going to explain you along X direction. See what force is going to act? F of X, that is a longitudinal force. Along Y direction, what force is going to act? Lateral force, that is F Y. Okay, wait for a minute. Yeah, so you can see this one. No, this one is Fy, and this one is Fx. Okay, and you can see this one is Fz. That is the force acting in Z direction. Okay. Now we'll be discussing about a moment about the different axes. You can see along Fx you'll be having the moment mx, and here you will be having my. I will be defining what is mx and what is my, and here you will be having what mz. Okay, and you can see this is known as camber angle. There is a vertical plane how far the tire center is going to make an angle. So this one we can say a camber angle, and this one is a slip angle. That is the tire is intended to move in X direction, but it will be moving in this direction. The deviation, slip angle is denoted by alpha. Okay, the slip angle is denoted by alpha. You can see this is alpha. Okay, slip angle is denoted by alpha. Now we'll be defining what are the different thing. I think the sketch will be clearer to you. Now I'm going to explain it. That is a f of y. What is f of y? That is F force acting along the y-axis. Okay, it is written by printing mistake. That is, it is a lateral force, whereas F of x is the force acting along x direction. That is a longitudinal force. And now we are addressing this force. No, F z. What is the meaning? That is F of x longitudinal, F of y lateral, and F z. We can use the word normal or vertical force. You can see I can use this normal or vertical force. And you have to understand the moment about z axis. You can see here the moment about z axis is called aligning moment, mz. Okay, so it will align the tire into the straight ahead position after completing a turn. And you can see mx. Mx is nothing but moment about x axis, that is like rolling. Okay, so we can say it is a overturning moment. Okay, then moment about y axis is called rolling resistance moment. So you have to understand this word. So this can be framed in objective. Okay, so this one will be moment about y is termed as what? Rolling resistance moment. So mx is overturning moment, and mz is aligning moment, and My is rolling resistance. So now I am giving a sketch. This one will be the more clear representation for understanding the longitudinal and lateral forces. You can see this one is longitudinal axis of the vehicle. That is, the vehicle is going to move in this intended direction, and you are seeing the tire. Okay, I am considering only one tire, and at the center of the contact patch only the forces are going to originate. You can see this direction lateral force, and this direction f of x, and del will be a steering angle. That is, you are about to go in straight, and you have made a turn. Okay, so you will be having an aligning moment. That is, your mz will bring back this wheel to the straight ahead position. So these are the forces that is going to act in a wheel when we are going to move in a straight ahead position, and when you are going to make a turn, when the steer angle delta is given, what will happen after negotiating a turn? This aligning moment will come into the picture. And this one you can see the tire structure. No, that is, I'm going to explain the two types of tire structure. Already you might have studied in automotive chassis. You can take the information from that content also. So here I'm going to give a just overview, and detailed information you please refer automotive chassis also. So you can see the tire structure. That what will happen? No, cross play means, that is, you can see cross play or bias play. You can see the tires will be having a plates, that is a cots. Okay, you can see it will be intersecting like this. Okay, you will be having a arranged in a cross fashion, and you can see the ply making with the center line, that is known as a ply angle or a cross angle. Okay, so this is known as a cross play or bias play tires. Okay, so this is a carcass. Carcass is a structure that will take the load of the tire. Okay. And you can see the next one, radial play. So in radial play, we will not have this diagonal pattern. We will be having all the threads will be running in this fashion. That is, radially the plays will be run, and you will be having the belt to stabilize. Okay, so that side force it can withstand. So that is the main angle. That is the main aim to keep this belt. Okay, this is known as a radial play tires. You can see the plays are running in radial direction. Further information you can get it from automotive chassis. That is, you may get a question difference between carcass and radial play. Okay, and what is the main function of this belt? Like this, you may get a question. So here in vehicle dynamics, I am going to describe just an overview of this tire alone. Detailed information already you might have studied in automotive chassis. You please refer that. Okay. So now you can see I am putting the tire designation. So you can see in the tire this one. This will be the standard interview question, as well as when we are going for any objective in automobile engineering, the questions related to tire, we will be having what? Tire designation. That is, you can see the first letter, no, it will indicate whether it's a passenger car tire or a truck tire. Okay. So P means the tire will be used for transporting passengers. And you can see 185. 185, you can see in the sketch, we are having a carcass, no? So this width is known as 185, and we'll be having the height. Will not be using the height, we'll be using the width and aspect ratio. And aspect ratio will be height by width. Okay. So you can see this 185 is the width of the cross section. And the height will not be mentioning it straightly. That is a 185 slash, you are putting a number, no? That is known as aspect ratio. So for tire, you may get a question, what is the aspect ratio? So it is a ratio of height to the cross-sectional width. Okay. So this height to the cross-sectional width, that is 180 is given now. So you using this 185 and 70, you can calculate what is the height of the tire. So 70 aspect ratio, you have to remember 70 is aspect ratio of height of the side wall, that is a carcass I have told, no, height of the side wall to the cross-sectional width. And again, we are having what? R. R stands for what? Radial play. If I'm going to put another word, it will be used for denoting what? Cross play tire. So radial play tire, all the plays will be running in radial direction. And after R, I will be having one number that denotes what? Rim. that denotes rim diameter in inches. I think you know what is a rim. You can see in the sketch. This is the rim. So over the rim only, I'm going to fit the tire. So the rim will be having the 5 bolt bolts that will be used for attaching to the axle. Okay. So this portion, you see the cursor movement. This is known as rim. Okay. So after R, whatever number is going to come, that will denotes what rim diameter. Okay, then this are the other terminologies. That is after rim diameter you are having 87. Yes, no. So 87 is the load carrying capacity of the tire. So based on the number I can load that vehicle, how much load the tire can carry. Okay, so it is a code indicating maximum load the tire can carry at the maximum rated speed. There is a vehicle is going to put into the operation at a maximum speed. What is the maximum load it can carry? So that is the indication of that code. And you are having the last, so you can see alphabet. That is a speed rating. That is what is the maximum speed. That is instead of having a number, we are denoting it by a alphabet. That is what is the maximum speed the tire can move. Okay. So for different alphabets, we are having what? Different speed. For example, you can see S stands for 112 meter per hour. So in kilometer per hour, I can say 180. So you don't need to remember everything. Just remember if it is yes, what is the speed? That will be the sufficient. And you can see afterwards you can have a traction and temperature capabilities. Okay, that is how far it can give the tractive power and how far it can withstand the high temperature. We are having a scale say A to C. So A will be the best and C will be the worst. Okay, so these are and all designation of the tire. And other definition you can see traction rating. So I'll be using the word traction rating. Traction rating. What do you mean by that? That is when you are traveling in the wet surface. No, you are going to apply the brake. So when you are going to apply the brake, the vehicle should come at rest in the straight line. So based on that rating, we are denoting what it is called as a traction rating. So in simply we can say straight line stopping ability on a wet surface. Okay, the traction rating is good. I can say my vehicle stability will be good. That is, I can retain my vehicle stability and vehicle handling on wet surface. And temperature ability trading already, you know, by seeing the word itself, you can guess that is how far it can withstand the heat and at high speeds as well as loads. Okay, so how far it can withstand the. Then another major thing you have to remember, thread wear index. That is, you can see for a tire normally you will be having some period, say 5 or 6 years. After that you have to replace the entire tire itself. Okay, so based on the thread, in Tamil we will say தேஞ்சு போச்சும்பாங்க. That is, you are having in a two-wheeler, thread வந்து தேஞ்சு போச்சு, இதுக்கு மேலே நீங்கள் டயர் யூஸ் பண்ணிங்கன்னா ஃபியூல் கன்சம்ஷன் ஜாஸ்தியாகும், அதே நேரத்தில் சேஃப்டியும் வில் கெட் அஃபெக்டட் அப்படிம்பாங்க. ஒரு பர்டிகுலர் பீரியடுக்கு அப்புறம் ஒரு 4-5 வருஷம் பேஸ்ட் ஆன் யுவர் யூசேஜ். ஓகே, ஸோ அதை வந்து டினோட் பண்ண போகிறது தான் எனது த்ரெட் வியர் இண்டெக்ஸ். த்ரெட் வியர் இண்டெக்ஸ். ஓகே, ஸோ த்ரெட் வியர் இண்டெக்ஸ் இன் அப்ஜெக்டிவ் தே மே ஆஸ்க். ஸோ இட் இஸ் இண்டிகேஷன் ஆஃப் expected tire life. It is an indication of expected tire life. Okay, so இப்போ பார்த்தீங்கன்னா we will be having one reference tire. Say index is 100 means what it is having a optimum life. Okay, so I'm going to compare. If I'm having a thread wear rating 420 means 4.2 times as long as the reference tire. Okay, so like this only I'm going to compare. So 180, if I'm having a thread wear index, so one saying you have to understand when I'm saying 200 wins, I can say compared to my reference tire, my tire life will be 2 times more than reference tire. The reference tire is going to come for 3 years. My tire will be coming for 6 years if I'm having a thread wear index say 200. Okay, so simple meaning only. And this one you can see the most clear sketch. Instead of showing a tire, I'm showing a wheel plane. Let me project it again. You'll be seeing a better. See, we're having what? A wheel plane. That is a tire. A torque is acting, and this one is a x direction. So you can adapt this sketch when it's going to come for a conventional exam. You can draw. You can see we're having what? Traction force. There is in traction force. We can use a word. This x direction is direction of wheel heading. There is a direction in which the wheel is going to rotate. Okay, and you can see in y direction lateral force, and in lateral force we are having a moment called rolling resistance moment, and this one is a z direction. So we are having what? Normal force or vertical force, and we are having what? Aligning torque. Okay, so you can see when the tire is going to in this intended direction, but actually it is going like this. So this is the slip angle. When it's going to make in the right hand side, it will be a positive slip, and when it's going to make in the left hand side, it will be the negative slip. And this one, I can use the word del stands for steer angle. This one I can use the word camper. Okay. So the wheel plane, the angle of the wheel plane with the vertical, I can term it as a camper. And already you might have studied in steering geometry. When it's tilted out, it will be positive. Tilted in, it will be negative, and causing a toe in and a toe out. So that is a thing behind it. Okay. So camper angle, slip angle. Please go through. Now I'm going to define this slip angle. You might have seen in the sketch. So technical explanation you can see there is angle between direction of wheel travel, okay, and line of intersection of the wheel plane with the road surface. There is a line of intersection of the wheel plane with the road surface. Okay, so that is the main thing. The direction of wheel travel with the line of intersection of the wheel plane with the road surface. So this x, that is horizontal x, which is perpendicular to z as well as y, no, that is called intersection of the wheel plane with the ground plane. Okay, and this one is actually the direction of wheel travel. So obviously it should go in this plane, but slight deviation will be there. Okay, so that angle is termed as slip angle. Okay, then already I have told you camper angle. So camper between xz plane, that is you can see here I am having what? A x plane and z plane. So my camper angle will be shown in xz plane. Okay, the angle the wheel plane and xz plane. You can use the word xz plane. So now the main thing in this sketch, what I am going to show now, whatever the lateral force that is going to generate in a y direction, it depends upon two parameters. One is a slip angle and a camper angle. So you understand this concept. Whenever we are having a lateral force, it is a function. The two angles is going to influence this. That is what? Camper angle as well as slip angle. You should be knowing this. Okay. So the lateral force will be the function of both slip angle and camper angle. Okay. So we have discussed about this. Now I am going to discuss about slip. Let me zoom out. I think it will be visible. Yeah, it is visible. So you can see what is a slip. That is first of all I will explain you what is a slip. Okay, then you can go through this slip ratio and all. And already I have told you in the first unit itself, instead of having one value, if I'm going to have a ratio, instead of having a transmissibility force, I'm going to have a transmissibility ratio, easily I can plot a curve. Instead of having the angular frequency, if I'm going for angular frequency ratio, then easily I can plot the curve. So similar to this, I'm going to have what? Slip ratio. So before understanding slip ratio, let me explain what is a slip. See, from engine, we are getting power. There is a rotational speed is getting converted into linear speed. Okay, so engine is giving what? Rotational speed, and the tire is going to rotate, and linearly we are moving. Ideally speaking, this rotational speed and linear speed should be same. Then only there are no loss. I am utilizing the engine power to the maximum extent. But in practical cases, this will not be same. That is, you can see rotational speed that is coming from engine. No, I'll be using the term R omega. That is, you might know it in engineering mechanics. Linear velocity v is equal to the radius multiplied by angular velocity. So r omega minus v, that will give what? Slip. Okay. So the difference between the rotational velocity, that is equivalent rotation velocity. I can use the word equivalent rotational velocity, r into omega. So here suffix w denotes wheel, and effective, r effective stands for effective radius of the tire. Okay. So here, if I'm going to use like this, there is r omega minus of v, and vx, everything is considered what? In x direction. So everything is considered in x direction. So I can say this as longitudinal strip. Okay. And if I'm going to put speed, that is, if I'm going to put this one r into omega at the denominator, as well as vx at the denominator, I'm having what? Slip ratio. There will be two slip ratio. There is one, I'm going to apply the brake, I'll be having one slip ratio. When I'm going to accelerate, I'll be having another slip ratio. You may ask why this slip ratio is getting different. That is, when you are starting the vehicle, no, you'll be getting the power from the engine. So what will happen in that scenario? The slip ratio, the input is taken as from the engine. That is, you will go for equivalent rotational velocity. When you are traveling in the vehicle and you are going to about the brake, my input, that is, I will be vx, I'll be having the linear velocity. So during braking, I am referring the slip ratio with reference to the linear velocity, that is vehicle velocity. Whereas during acceleration, my main criteria will be I am getting the power from the engine, so I am going for equivalent rotational velocity. So you have to understand. See, the difference is main thing. The difference is main thing. There is a difference between the rotational velocity and the Vx. Always rotational velocity will be more compared to linear velocity. But for calculating the slip ratio, for braking, I am taking a linear velocity as reference. And for acceleration, I am taking rotational velocity as reference. So you have to remember this. Okay. And what they have done, no, you can see in this book. So there is a Rajesh Rajamani. They have done research in that, and they have plotted a curve. Okay, so already we are having most of the vehicle dynamics engineer. They might have understood slip, and instead of going for a slip, they are going for slip ratio, so that you can see what is the main benefit when you are going to have slip ratio. Let me explain. See, in this curve, you are having slip ratio, no? That is you can see the value easily: 0.1, 0.2, 0.3, and minus 0.1, 0.2. So the values are less. If I'm going to have a slip, no, I will not be having the predefined value like this. It will be changing, and I can't use it for putting in the graph. If I'm putting in a slip ratio, I can easily understand the variation of the force, either longitudinal or lateral force with slip ratio. You can see in this curve, I am going to plot a curve with longitudinal force. Longitudinal force means force in x direction. That is depending upon the direction. I am classifying it as positive and negative. So 1000, and if you are having what? Minus 1000 Newton. Okay, so I'm having the scale like this. You can see the curve that is during braking. Okay, so this one will be during braking. During braking, you have to understand longitudinal force will be a tractive force. Understand carefully. Longitudinal force will be tractive force that will be acting in this direction. You see, that is from left to right. During braking, it will be acting from right to left. So that only you can see negative sign is given. Okay, so initially I am plotting a curve. Okay, that is a tire forces versus a slip ratio. You can see the tire forces will be taking a negative value because it is acting opposite to the vehicle motion. Okay, so how far it is going to get varied? Okay, so whenever I am going to have a slip ratio, that is whenever I am going to have a slip which is going to get increased, you can see zero point 0.3, zero point 0.2. Here I can say it is getting increased. Okay, so what happened? My my longitudinal force is getting reduced. Okay, and this variation, no, is not linear. That is, it is for understanding this variation, it's not an easy task, because multiple parameters getting influencing this tire force. Thus, you seeing this curve, we can't say only the slip ratio is influencing this tire force, other factors also influencing, but only in this region, say minus zero point 0.1 to zero point 0.1. You can see if it is, I am increasing the slip. Okay, you can see there is an increase in the tire force. So I am having a linear relationship only in this small interval of slip ratio. Further increase in slip ratio, you can see further I am going for a non-linear curve, so the relation is not linear. That is for axis. Okay, so we have to concentrate on this slip ratio minus zero point 0.1 to zero point 0.1. That is, we can say my tire force is linear. Directly, I can calculate how much tire force is going to act by using this curve. That is by finding out the slip ratio. Okay, so in this portion only, I can adapt a formula. Okay, that is a minus zero point 0.1 to zero point 0.1. I can adapt a formula. That is, you can see tractive force f of x in the front, f of x in the rear. If it is acting in the direction of the wheel, I can say it is a tractive force that is in a vehicle motion. If it is acting opposite to the vehicle motion, I can say it is a what, retarding force, that is, it is a decelerating force. Since in this region of minus zero point 0.1 to zero point 0.1, it is a small region and it is a linear region. In that region, I can adapt this formula. That is, I can say my force, that is longitudinal force, is directly proportional to the slip ratio. That is, longitudinal force in the front depends upon slip ratio in the front. Longitudinal force in the rear depends upon slip ratio in the rear. So once I'm going to remove that constant of, when I'm going to put the constant of proportionality, you'll be having what? C sigma F. Okay, there's a longitudinal stiffness. C sigma R. So I can use this formula only in this region, minus zero point 0.1 to zero point 0.1. Okay. So you have to understand this one, C sigma F, C sigma R. It is called what? That is, I am studying the parameter of the tire in longitudinal direction. That is, I can say longitudinal tire stiffness. Okay. So I can say longitudinal tire stiffness. Okay. So you have to understand this two, no? C stands for longitudinal tire stiffness. That is for front and rear tire. That is similar to our spring. That is when we are dividing the force by deflection, you will be getting the stiffness, no? So similar to that, we are having this expression. That is when I want to find this stiffness, longitudinal tire stiffness, what I have to do? I have to divide this force by this slip ratio. Otherwise, I can say that is my longitudinal tire force is directly proportional to the slip ratio in this region. Okay. So in order to find, I'll be having what? C sigma, that is a longitudinal tire stiffness. It is a constant. Okay. So it depends upon the property of the tire. Okay. It will not be varying. Only the varying quantity is linear, the force, and this one, my C will be the constant. Okay, that constant can be adapted in this narrow region. There is minus zero point 0.1 to zero point 0.1. So it is a, for every tire we'll be having a different stiffness parameter, longitudinal stiffness, vertical stiffness, and lateral stiffness. Okay. So you can see. Let me discuss about this one. You can see we are having a wheel. It is running in this direction. Okay, that is I am having a vehicle motion in this direction, and from the engine I am getting what, a rotating motion, that I will be calculating it by R effective into omega. That is, I can say R into omega. Okay, the effective radius of the tire and the angular velocity of the wheel. So my longitudinal motion is this one, and you can see there will be the difference. This is known as slip. Actually, during acceleration, my rotational velocity will be greater than linear velocity. So what will happen? You can see this difference. This difference plays an important role in slip. Okay. So what will happen? That is, this difference will be taking into account when the threads are going to make in contact with the road. That is, you can see you are having a thread, no, that will be making a contact with the ground. So in this region, I can feel this difference. That is, I can feel the difference between the equivalent rotational velocity minus the linear velocity. Okay, so you can see when tire, we can model the tire like a spring. So whenever the springs are going to enter into the contact region, uh, initially at the center, the springs will be getting compressed. Then after that, it will be getting elongated. Okay, so that is a hysteresis property. Whatever is going to get compressed will not be getting elongated completely. So it will offer a resistance. That resistance is termed as rolling resistance. Okay, so we are having you can see two regions. That is a static region and sliding region, and this one is a contact patch. Static region, you can see the springs are not getting deflected. Okay, in sliding region, the springs will be getting deflected. Okay, so you can see what I have explained. That is, there is a difference between the rotational velocity and the linear velocity. So whatever the thread, that is, whenever a thread is going to make a contact with the ground, what will happen? The net velocity. So this one is at the thread, this one is greater. So the net velocity, the difference will be felt at the thread. Okay, so you can see at the thread, what will happen? The resultant velocity will be opposite to the longitudinal velocity. So it is written, see, the net velocity that is in the thread, it will be opposite to the longitudinal velocity. Okay, so that is known as a slip, and normally this will not, the difference will not be more, it will be somewhat less only. So under that region, that is when the difference is going to felt, the thread are going to get contact with the ground, you will have the spring elements getting sliding. Okay, so you can see there are two regions, static region and uh, sliding region. When the difference is less, we'll be having the static region. When the difference is more, we'll be having what? Sliding region. That is, you can see the slip is small. What happened? The thread element will not slide. So that is a static region. And further movement of the thread, what will happen? It will be entering into the sliding region. Okay. So that is the main thing. You can see. So that and all the explanation is given. Just you can go through. So mainly the time duration in which the thread is going to remain in contact with the ground, no, is inversely proportional to the rotation velocity. Okay, you can go through this. So finally, I can say that is how far the thread element is going to get deflected. It depends upon my slip to absolute velocity. That is, if the slip is more, maximum deflection will take place. Okay. So next, we have to discuss about lateral force. So today we have discussed about longitudinal force. So next class we'll be studying about lateral force. Okay. So we'll be discussing the lateral force, how it's going to vary with the slip angles. Okay. If you're having any doubt, you can ask. Otherwise, you can leave the class. So today we have seen the introduction of the tires, and we have seen what do you mean by longitudinal force. So for your objective, you have to go through this formula alone. This curve that is within this narrow region, this will be linear, and that why it is happening. Static region thread element will not get deflected because the slip will be less, and sliding region, the because it is going further more there, the greater difference will be there, so the thread will be getting deflected. Okay, so if you are able to go through this entire information, it's well and good. Otherwise, just observe this alone. Okay, since it is objective. So we have completed the longitudinal tire force. Next class we'll be completing the lateral tire force and other things. And if you're having any doubt, you can ask. Otherwise, we can end up the class. Any doubts, ma'am?